Hello, everybody. Welcome. My name is Aziel, and this is Fernando. We're both engineers on Airbnb's privacy engineering team. And today, we're going to share our work in consent management. In this talk, we'll start by discussing the problem we wanted to solve with regards to cookie consent, what we built, and other solutions enabled by our platform. So we'll start talking about the cookie consent problem. As privacy engineers, our primary concern is maintaining compliance with the e-privacy directive. We must first gather a user's consent before we use any non-strictly necessary cookies. As Airbnb privacy engineers, we want to deliver a user experience that empowers our customers to control what data they share with us and how we can use that data. These screenshots show our cookie banner, which empowers our customers to control specific cookie groups. This UX is currently powered by our consent management platform. We'll share how we improved upon our legacy cookie banner solution to generalize it to solve many consent-based gestures, which empowers our customers to take more control of their data. Our legacy solution surfaced a similar shaped cookie banner shown on the previous slide, and it correctly collected customer consent to those cookies. However, it had some limitations in operational and extensibility concerns. In order for us to ask our customers for consent to new features, we had to deploy and coordinate client and server changes. Consent banner updates were not propagated without a client app update. This slowed down our development cycle and caused us to pause some native client feature releases that required customer consent until this issue was resolved. It was difficult to expand the solution to solve other customer consent gestures beyond that cookie banner. Other consent gestures like terms of service or global privacy control were impossible with the previous solution. And additionally, consent regulations vary in different regions. So the previous solution was not able to handle those variation in consent requirements because in the previous solution, the same cookie banner is presented to all our users all over the world. In our consent banner, we have to describe and model different categories of cookies or trackers that a user can consent to. We had categories like strictly necessary, functional, targeting, and performance. The cookies and SDKs related to those categories can evolve over time, and the original solution was not able to adapt to those problems that we had. For example, reclassifying a cookie from strictly necessary to functional required both server and client changes, along with a coordinated launch. And even with that coordinated launch, unless we forced an app update on our native client users, we would still have that long-tail app version problem where a fraction of our users are still using the old version of the app and could have a non-compliant customer experience. But forcing an app update would hurt that user experience and in-app conversion. So that would be a non-ideal solution to the compliance problem. So considering those problems we mentioned, we'll now show what we built, our consent management platform, aka CMP. To address pain points with our previous solution, we took the learnings of our stakeholder teams and used them to lay a foundation for the platform we wanted to build. We needed a system that is configuration-driven so that our different clients can specify the different things that need user consent. The system must allow for client specificity, so they'll share a base schema but it can extend it into their client-specific requirements. For example, our needs in the web client are different than that of the iOS client, which is also different than that of the Android client. We needed to minimize the client-side logic concerning gathering and persisting consent while allowing for backend-only updates to collect new consent. This improves our development and delivery velocity. So we'll start by describing the concepts that we would work with. The first concept is a term, the thing a user can consent to. So in this context, a term can have a name like strictly necessary and have a list of cookies that are covered by that category. it can also have a different meaning in the different clients. For example, in web client, strictly necessary would mean one thing, but iOS a different thing, and Android also a different thing. A term can either be accepted or rejected. Consent is the gesture of a user's acceptance or rejection of the presented terms. A tenant is the service or client that uses CMP to render and store consent data. And consent record captures the terms that have been accepted or rejected by the user. It's meant to be immutable, and the collection of consent records in our data store serves as an audit log for investigation purposes. The consent configuration describes the tenant of the consent management platform and the collection of terms that are modeled in it. We use this configuration to describe more metadata about the terms, such as user-readable descriptions, cookies related to the terms, SDKs related to the term, functionalities and entitlements that acceptance of that term grants, and the flexibility of this configuration allows this model to be adaptable to future unknown requirements. Some details about the term. You can see here that there is a schema describing the cookies that belong to the Airbnb targeting term, along with a human-readable name and a description. We also specify a category for the terms that can help the client organize this information in a sensible way for presentation. And here we show a configuration. The configuration is defined by an ID, which contains a list of the terms it represents. The ID schema was chosen to allow for variation of consent between different regions for the same tenant client. For example, the consent requirements of one country may differ from the common global configuration. And so by allowing the configuration ID to scale to that possibility, we allow specific region configurations to be written. Here we persist a user's consent in the consent record. And you can see some metadata about consent capture time, expiry time, the configuration presented to that user, and the accepted and rejected terms, and the user ID and device ID. This metadata helps us determine whether or not we need to present a user with new consent and the next time they visit the Airbnb app. And to tie all those concepts together, we needed an API surface for our client apps to interact with. Based on our client app developers' feedback, they desired an API that solves two gestures. Show consent answers the question, should I prompt the user for consent? If yes, how do I render this consent banner? If consent does not exist, we'll use the configuration to help render the consent banner. But if a consent exists, we return the expired time and the list of terms that are accepted and rejected so that the client can use those to educate its logic. Submit consent allows the client to send a proposal to CMP. This proposal shows the accepted and rejected terms for a specific configuration so that we can validate that proposal input before persisting it as a consent record. In the next few slides, we'll illustrate this workflow of how we model the new consent term and collect and persist consent for it from the user. So here we show the configuration design time and how an engineer would write a new configuration to collect consent for the web banner. The engineer would write the configuration schema, which here shows security term and Airbnb's strictly necessary term. You can also see the cookies that are related to it and the user-readable name. When a user navigates to the Airbnb website, this web application will query the show consent API to determine if this user-device pair needs to be prompted for consent. In this case, the show consent API responded with show consent is true, and then a view of the configuration metadata so that they can render the consent banner. After the user interacts with the consent banner, the web app arranges the banner input data into a proposal and invokes submit consent to persist it into the backend. So turning the presentation over to Fernando, who will discuss the features and functionalities we've enabled due to this work.
Right. Thank you, Aziel. So Given our backend flexibility and capacity to provide consent records and complete configurations for one or many terms, we built a website platform capable of getting this consent information and propagating the records in a way that can be used at various levels of the tech stack and different times in the natural execution flow of the application. The platform has a central store populated by consent operations that can call our backend. The operations will return the consent records for one or many terms and pass them to the store with arguments to persist them in the client or keep them temporarily available in memory. The consent will then be propagated to different modules through context or attached to data stream function that works like subscription to consent changes. With the power of our backend resolving geo-specific and other conditions for us, plus the web platform capable of propagating these consent records, we built many features on top of it. For instance, as our previous presenter mentioned, we also support the global privacy control signal that is sent as a header from some browsers and as a value in the browser navigator object. We solve this at server-side level when there is a check of the GPC header that doesn't exist. Our middleware will trigger a request to our backend, and finally, it will propagate our store with the values from that response. Another example is when the UI components initiate the action. In this case, a user will see the page like this and click the opt-out button. So the React components invokes the submit consent operation callback. The response propagates to the cell opt-out consent record to the store, which right after propagates a cell opt-out term value to the context and many data streams subscribe to that term. We also support more complex implementation that runs server-side and client-side. At Airbnb, we built and adopted a single storage library to manage web storage technologies like cookies, local storage, etc. Other modules import and use the unified library, which at runtime restricts access to the values marked as non-strictly necessary and that their user hasn't consent to the. Internally, the unified library accesses the persist consent information from the consent propagation platform store, previously captured by our cookies banner as terms.
So we have to cut. We're at time, but we got to our last slide. So these are the takeaways from our presentation. Thank you for having us here.